What's up everyone, it's Red Saber here from Saber C++, and today we're continuing with creating this Tetris game. So grab your MicroCade and let's get started. Let's start by adding collisions so we can determine where our Tetris pieces can fit. Remember, our pieces are made up of X's and dots, so we can ignore the dots, but we need to check if any of the X's are overlapping in order to check for collision. Let's create a Boolean function called bool doesPieceFit with an int tetromino int rotation, int pos x, and int pos y. Then we can loop an int called px from 0 to less than 4 and an int called py from 0 to less than 4 inside of that. Inside of both loops we can create a piece index which I'll set to rotate px, py, rotation, so we'll have the proper index for this rotation of the piece. Then we'll create an int field index which I'll set to pos y plus py times field width plus pos x plus px. So we'll get the value of the field at the proper position, not just for the piece, but for the specific square inside of the piece that we're currently on. The last thing we need to do is check if the piece is in bounds. So we can check if pos x plus px is greater than or equal to 0, and pos x plus px is less than field width. And if it is in bounds on the x, we'll check if pos y plus py is greater than or equal to 0, and pos y plus py is less than field height. So if the piece is in bounds, then we'll want to check if the tetromino has a collision. So if tetromino num piece index does not equal dot, and the field at the field index does not equal 0, so if the piece isn't empty and the field isn't empty, we'll return false because the piece doesn't fit because there's a collision. At the end of the function, we'll return true because if we've gotten to this point, then we haven't returned false, so the piece must be able to fit. So now we can check collisions, but we aren't doing it yet, so let's add that next. At the top, we'll add a few more variables. Int current piece equals 0, int current rotation equals 0, int current x equals field width divided by 2, and int current y equals 0. These will hold what the currently falling piece is and how it's rotated and positioned. We're also going to need a character output array with 216 members, which I'll create after the field array. The field array will contain all of the set field elements, including the walls and stopped Tetris pieces, but the output array will also hold the moving Tetris piece so we can display it. So in the loop function, inside of this while loop, but before we output the field, let's fill up this output array. So we'll loop an int called x from 0 to the field width, and an int y from 0 to the field height. Inside of this, we'll say output at y times field width plus x, and we'll set that equal to space a, b, c, d, e, f, g equals pound sign, and this will just be an array of all of the characters that we are going to use, and we'll select an item from this array, and the item we want to select from this array will be field y times field width plus x. So basically, we're getting the value of the field at the same position as the value of the output that we're setting, but instead of passing in 0 or 1 or 2 all the way up to 9, we're passing in space or A or B all the way up to the pound sign. So we're switching from a number to one of these characters. Space, of course, will be empty space, A through G will be the different characters, equals we'll use later, and pound sign will be for the order of the field. Then we'll need to add our currently moving game piece to the output. So we'll loop an int called px from 0 to less than 4, and an int py from 0 to less than 4, once again. And we'll say if tetromino current piece rotate px, py current rotation does not equal dot. So if the currently falling tetromino is solid at this exact position, then output current y plus py times field width plus current x plus px should be set to current piece plus 65. Now 65 is the decimal value we use for a. So if the piece is 0, the long straight one, then we'll be using the letter A for each of the solid points. So it'll be 4 A's in a row. If the piece is 1, we'll add 65 to get 66, which is the value that represents B. So we're just using a different letter for each piece, just like we did up here, but now for the actually falling piece. The last thing we need to do is go into output field and change where it says field I to output I in both places, so that we're outputting the output array and not the field array. And as you can see, we're now printing out a piece inside of the field, and it looks much nicer than before. We've made a lot more progress, but we're still not done, so make sure to watch the next video where we'll make the game actually playable. Be sure to subscribe so you don't miss the rest of the series, and I'll put the next video there on the right as soon as it's available, and you can check out my channel on the left for more tutorials about Arduino and the MicroCade.